Alright, so this video will be about skills strategy, including how to program an autonomous run and how to plan out a successful driver run. So in skills, it's really important to first look at the game and find the biggest points because you only have 1 minute and you want to maximize your points. So the biggest point values in this game is the green cubes. Obviously the red and blue cubes are half the point values and require a lot of movement from cross field to crossing the field. So obviously the green cubes have to go on to the platforms, and Dane can show a little bit of a driver run of how that would happen. So, the obvious choice since the starting play is to immediately drive across and get that first cube straight away, straight across, and then go for the third cube, which he dropped there, but it's okay.
Must be scored.
Yep, it's still scored. Then you can get that third cube. And place it over there. But autonomous is a little different because there is a rule that says you can pick up your robot in the middle of a autonomous run and place it. And since there is a place where the robot can go right here and over there, you can create the exact same code that runs right there, picks up a cube, goes straight across, places it there, and run it exactly right here to get that second one, which means there's an obvious way to get 40 points in this game really easily with just a couple lines of code to go straight across, pick up the cube, and place it on there. So that's what we'll be doing, is showing a little bit of how to program an autonomous run, how to improve it and such.
So we're going to create two different scripts. One of them is going to be used to get the two lower ones. We're going to use down, and we're going to have another one, and it's going to be used to get the one high. We're going to use the up button for that. Just like using correlation of up and down to signify things is useful. So we're going to start with, on this one, setting drive. We're going to set drive speed to like 60, something kind of slow but not too fast. Actually, yeah, let's make it slower.
In general, in autonomous, you want to go for slower than faster, especially when you're just trying to get done a small amount of things in that 60 seconds, because if you start off slow, as you build your autonomous program, you can speed up things that you know can go faster, but you want to start slow because that means that you can get a task done with more reliability, because higher speeds is more risky and more able to cause problems.
Yeah. So we're gonna have wait. We're gonna want to set some claw states.
So we have these claw position variables which we programmed states into them, which is other advanced programming types. But of course, you can just do a normal in the motion. There's things like turn motor to this amount of degrees and stuff like that to lift it up to the height you want. So you don't have to use states like we do. You can do the same way, but with the already in
these numbers are completely just guesses. We have no idea what the actual correct thing. We're gonna find that out once we start testing.
Yep. A big part of autonomous programming is just programming a chunk of it and then testing it on the field, changing the numbers until you get it right, and then working on another chunk. So we call, when we're just putting in numbers and giving our best guesses, we call that like blind programming, and then we then adjust it on the field.
So what I have here currently is it's driving forward, and while it's driving forward, it's going to close the claw after a little while, which is going to close the claw on the cube. And it's going to lift up to the state 1, which is the state where it is going to be at the correct position. And then it's going
to go on the platform, to be above the platform.
And then we're going to wait a little bit longer, and then we're going to close the claw, open the claw, it's 0. And then we're going to want to drive back. So let's wait a little bit, like 0.5 seconds. A little bit. Let's wait a little. We have some time, so we can wait some time to let the claw run out. Then we're going to want to drive speed -40, sure. And then we're going to want to wait a little bit longer for it to get off that, and then we're going to want to stop it because we don't want it to just keep going while we try to reset it. We want it to, we're going to want to set it to 0 because we don't want it to, like I said, we don't want the wheels to be moving while we reset it. So that's going to, and then we can use this exact same thing on the other side. So let's
download it and try this just to get those low cubes.
Yeah.
Yep.
Alright, so we're gonna do a test run of this program that we just created. Gonna reset. We're gonna hit down. So of course it didn't work. That's just how programming is. And now what we're gonna do is we're gonna think about what happened there. We're gonna go back and change it. First, like we said, the first thing we need to do is change the beginning because it drove way too far before it set the claw state to 1. So we're gonna set this to like 1.2, maybe. It's always good to take a video of your code. We have a video here. It's always good to take a video of your code so that you remember what happened.
Yep, so while you're programming, you can see what happened wrong and even like slow it down and look at closely what happened.
So what it did not close the claw. So I'm gonna say 1.2. It's a lot of just guessing and checking. That's what a lot of this is. It needs to go less before lifting it up. So let's make that 0.5. You also want to add a bit more. We also want to add a stop here. We're gonna want to have it stop. It's gonna be 0, and this needs to be drive speed. So yeah, it needs to go maybe a bit further before doing that. Yeah, I'm thinking this looks good. Yeah. And then another thing that I saw is we want to have it at the exact same position. We want it to start at a good position when we reset it, because this starts at lift state 0, claw state 0, but this used to end at lift state 1. So we're gonna want to at the end set it back to lift state 0, so that when we reset it, it's going to
go back to the same. Yeah. So when you're programming like this in sections that you reset it in the same spot, you always want to have it at the end of each section to set it back at the same rotation or same placement for each of the mechanisms, so that when you reset it, you don't have to like move the rope. So you don't have to move any of the parts.
Okay. Already download it. All right, so we're back to testing again. We're gonna run the program again. See what happens. So, like we saw, what our changes already made. It picked up the thing earlier. It picked up everything fine. All we need to do now is we need to have it go further before releasing the claw. So
back to the computer.
So now we know that we need to go farther. We need to change this variable, which is the time before it stops and releases. So we're gonna change this variable to, I'm gonna say like 3 seconds, maybe 3.2. It's all just like you can look at the video you had and make approximations, and you can just And that's how programming is done. Alright, so let's download this, and we're going to go back to the field. Third time back at the field. I'm going to try this. Alright, it worked. Alright, so let's try it over here. Because how a normal autonomous run would work is we would then immediately grab it and put it over here, hit the button. As we can saw there, we saw over there as well, is that it went a little bit too far. We can go back and change that, but it works. So we're back. Another thing we need to add is, that we saw earlier in between, is that we had some gyro drift near the end of the thing. So what we're going to want to do is we're going to, at the beginning of this program, set the gyro heading to 0. But what that'll do is reset all of the gyro drift that is accumulated over the course of the time of the autonomous. Another thing we saw when we look back at the video is that there was not enough time between this setting of the call state to 1 and the lift state adding, so it's like it started to pick up a bit. The picking up was a bit weird. So what we're gonna do is we're gonna add 0.2 to this, and we're gonna have to subtract 0.2 from this. But we also saw that it went a bit too far driving wise, so we're actually gonna take off 0.5. Yeah. All right. So now, yeah. So that should all be good. All right. So first, we're actually gonna run this first cube first because we actually made some changes previously. So let's run that first. So you can see it waited a little bit longer, and it just perfectly. So now we're gonna start working on this, and it started out pretty similar. Just a drive speed 40. Weight 1.2.
Alright, so while Dane's assembling some of the beginning parts, the gist of what we're doing all here is this back and forth between testing the program and adjusting values, and that's really how you do autonomous program, is through these just long sections of waiting and setting drive speeds, and in this one we can see how you do the turn through this as he's building that up right now. So while Dane is all doing this in his head and how he's seeing how many seconds like when to turn, another good way for the is to draw out a actual plan and see those degrees that you need to turn. So drawing out the plan for the program and seeing where you need to turn, and always having that reference of which way the robot's facing, because with this gyro programming, those degrees are not based off of where the robot was, but where the gyro was reset. So it's not turning, when he puts in 180, it's not turning a full 180 for where the robot is. It's actually really just turning 90 because the robot was already on that heading of 90.
Alright, back at the field, we're gonna go another one. Alright, well, there you go. Alright. Alright, so thank you for watching this webinar.
Yep.
Yeah.